So I'm going to go through the answers to the questions I set on Tuesday. All right, so you should have read this text here and then answered the questions. If you haven't done that, you need to pause the video now and get this document either on your computer or you might have printed it out and read through the text and then answer the questions and then start the video again. Otherwise, let's get started. So what is a fossil? So the first sentence, a fossil is the preserved remains or traces of a dead organism. Okay. Which type of rock would fossils be most likely to be found in? That would be sedimentary. Okay. Because you'll remember that sedimentary rock forms, let's say, under the ocean, where rock that's been transported after weathering is deposited down to the ocean floor. Okay, and as that happens, you might have a fish here, and that fish dies, and it also gets deposited and gets stuck inside all of the rock. All right. Now that rock, that sedimentary rock, then is going to contain the fossil, but it might be subjected to heat and pressure and turn into metamorphic rock. But if it's subjected to heat and pressure, the fossil will get destroyed, and so it won't be present in the metamorphic rock. Or if the sedimentary rock turns into igneous rock, first it needs to be melted and then it needs to freeze again, and during that melting process the fossil will be destroyed. Okay, so you wouldn't find it in metamorphic or igneous. What are the two conditions needed for sedimentary rock to become metamorphic rock? Heat and pressure. What are the two types of igneous rock? They are intrusive and extrusive, and you should be able to tell me what the difference is between them. So have a look and think now, what's the difference between intrusive and extrusive? Okay, so intrusive is formed inside the Earth's surface slowly with large crystals. Extrusive is formed outside the Earth's surface very, very quickly, very small crystals. How can mountains grow or islands appear overnight? That could be volcanic eruptions. Some of you might be familiar with the volcanic eruptions in Hawaii. So a lot of the islands in Hawaii, they're all the result of volcanic eruptions, and so some of those islands are still growing. And you could, if you go on the internet, you can do some research about that, about the volcanoes in Hawaii. What is the theory of evolution? All right, so this is going back a little bit. So this would be the development of organisms over millions of years through a process known as what? And this would be where I would have one of you put your hand up and you get a positive log for saying, well, not positive log, you get a merit for saying natural selection. And you all know all about natural selection. Okay, the organism best adapted to the environment, you'll remember, is the one that passes their genes on to the next generation. So how do fossils provide evidence to this theory of evolution? All right, so this is a little bit more difficult. Okay, so what we can do is we can see the development of the organisms in the fossils. Okay, so let's imagine we might have this organism here. All right, this might be from, let's say, 10 million years ago. All right, and then this one here would be the same organism, but from, let's just say, for example, 9 million years ago. Okay, I'm just making these numbers up. These aren't necessarily the numbers that they would be. Okay, now there's a million years difference. Okay, but it's the same organism, but we might see slight changes, slight variations between the two examples of the organism. So let's say this one's got a slightly longer thing on the front here and slightly longer arms around the side here. So we'll be able to see that kind of variation over the timescale of the fossils. Because these fossils are preserved for millions and millions of years, we can see, because evolution is the development of organisms over millions of years. So if we've got these examples that span millions of years, we can see how they develop during that timescale. Okay, and you can go on the internet and you can do all sorts of interesting research about that. So if you are interested in that, you can look up, if you search for things like, this one's difficult to spell, Archaeopteryx. Okay, so Archaeopteryx is a fossil that shows the connection between dinosaurs and birds. All right, and you can also, if you just do a search for Lucy fossil or Peking Man, these are fossils that show ancestors of modern humans. All right, so they look, you'll remember when we did evolution, they look a little bit like, our remains would look like, but they're slightly different, so you can read more about those. Okay, and finally, label the diagram. Let's go back to the rocks. Label the diagram, show the structure of the Earth. Okay, so this, I've got 5 things here. Really, I should only have 4. Let's not worry about that one. If you were a little bit confused about that, don't worry. So right in the center, we've got the inner core. Then we've got the outer core. Then we've got the mantle. That's the big one. And then we've got the crust. Okay, so remember, at any point you can pause these, go back, read it again. All right, let's just carry on then. So, next, 61, complete the table by describing how each type of rock is formed. Okay, so sedimentary, you've got it in the notes, so you need to have some description of weathering, transportation, then deposition, sedimentation, and then the last 2 are compaction and cementation. So the best kind of answer would have all of those words in it. Metamorphic would be action of heat and pressure on igneous or sedimentary rock. And igneous is formed from molten rock, cooling, and freezing. So you really need to know how all 3 types of rock are formed. Explain how rock from hills and mountains can become sediment in a riverbed. All right, so we've just answered that up here, so your answer is the same one. Explain how sedimentary rocks can become metamorphic rocks and igneous rocks. So sedimentary rocks become metamorphic rocks through the action of heat and pressure. Sedimentary rocks become igneous rocks by melting, okay, and then freezing again. So melting and freezing, okay. Now I'm going to stop here for a second, because this idea of magma or lava freezing to form igneous rock might be a little bit confusing, because you've got in your mind this idea of water turning into ice, and that process is called freezing. And you've got this idea that freezing is to do with it being really, really cold. All right, but then if I talk about lava turning into igneous rock, and I say that this is freezing as well, it might seem a little bit confusing, because in your mind you're thinking, well, freezing is when water turns into ice, and that's really, really cold, but lava is really, really hot, and igneous rock is just normal temperature. So how can that be freezing? Okay, so you need to remember that freezing has got nothing to do with it being cold. Freezing is when it turns from a liquid to a solid. And that's what happened when lava turns into igneous rock. Okay, so your sedimentary rock will melt, it will turn into a liquid, and then it will freeze and turn into igneous rock. Oh, okay, so here we go. Yep, forgot I had this question in here. So this is the one that I just recommended that you look up. All right. What type of rock would it be found in? Sedimentary. What do fossils tell us about life on Earth? They tell us about evolution. And explain why the fossil record is incomplete and is unlikely to ever give a complete record of living things on Earth. Okay, because fossils are destroyed when sedimentary rock turns into igneous and metamorphic rock. Okay, and I think we've still got one more section of questions to do. All right, these revision questions, you haven't done these, give it a pause, get them done now, otherwise we'll carry on. Okay, so this is the really full, quick recap. What are the 3 parts of the Earth core? You might be thinking, what, 3? I thought you said 4. Okay, remember it's the core, the mantle, and the crust. And the reason sometimes it's 3, sometimes it's 4 is because the core can be the inner and the outer core. Okay. What are the regions of rising hot liquid in the mantle core? They are called convection currents, and they are responsible for the movement of tectonic plates. Which type of rock is formed with liquid magma, formed from liquid magma inside a volcano? That is intrusive igneous rock. Which rocks are formed when lava is cooling quickly outside a volcano? Extrusive igneous. Which rocks are formed from layers of sediment? Clue is in the name, sedimentary rock. Which 2 conditions are needed for sedimentary to turn into heat and metamorphic? Heat and pressure. Complete the table. Well, we just did this, didn't we? So normally, you know, there'd be a bit of a gap between when you do these ones, but you'd have done them immediately after one another. And the same for fossil. We just did fossil. Why are fossils not found in igneous and metamorphic? Because they are destroyed. We just did that. And complete the table below to correct the common misconceptions. Okay, so here we go. So convection is when heat rises. Now we haven't done that in that much detail because of the situation. So don't worry if you couldn't do this one. We'll do convection in more detail next year anyway. So it is to do with heat, but it's when hot liquids or gases are less dense and therefore rise. Okay, so yes, convection is to do with heat and things rising, but they rise because they are less dense. That's the important thing. The continents are now no longer moving. False. They are moving. Evidence. Volcanoes and earthquakes. Okay, so if they weren't moving, we wouldn't have any volcanoes or earthquakes, but we do have volcanoes and earthquakes, so they must still be moving. Because the continents are part of the tectonic plates. And earthquakes result from tectonic plates crashing together. No, so tectonic plates move very slowly. And earthquakes are caused when built-up pressure releases suddenly. So you can imagine you might have done this in geography. Let's say you've got 2 plates. All right. Let's say, for example, this is the Pacific plate, and this is something called the Eurasian plate. So that's the plate that Europe and Asia is part of. All right. Now, I'm not sure 100% what this boundary looks like, but let's imagine, for example, the Pacific plate. Sorry, shouldn't be the Pacific. Getting my geography wrong now. This would be Atlantic. All right, so let's imagine, for example, again, I'm not saying that this is exactly what's happening, this is just an example. Let's say the Atlantic plate is moving in this direction, okay, and the Eurasian plate is moving in this direction. Now, it's happening very slowly, but because they're moving in opposite directions, okay, they might, at some point, get caught, okay, and then there'll be a build-up of pressure where the Atlantic plate's still trying to move this way, and the Eurasian plate's still trying to move this way, but they're caught here, and then eventually it'll release, and there will be an earthquake. All right, and that would be the epicenter of the earthquake. Okay. All right. Really, very good. So that is the end of the rocks and the rock cycle topic. I hope you've enjoyed it. It is normally a very interesting topic, but it's difficult to get that across through the medium of the internet. So do some further research if you've got time. The only other thing I want you to do is to do the end of topic quiz that I've set up on Google Forms. Okay, now when you're doing that, be really careful that you put your email address in correctly. Last time a lot of people put their email address in wrong, so they wouldn't have been sent their results afterwards. Okay, so I'll give you until after half term to do that quiz. All right, take it seriously. You know, it's not something that you should just rattle off in 5 minutes. You know, think about the questions carefully and try and get full marks. All right, good luck. See you after half term.